Hey everyone, so what we're going to be working on today is we're going to continue our notes in 4-6 over graphing, cotangent, and tangent. So let's go ahead and get started. The first thing that I want you to do is I want you to graph the cotangent graph like you were graphing on, say, a memory quiz. So go ahead and take a few minutes and graph the cotangent graph on the grid below. Okay, so we should get this as our cotangent graph. Cotangent starts 2 tick marks from the y-axis. It starts on the midline down here, and it goes to the left and up, and it goes to the right and down, specifically amplitude of 1 in this case. So what I want to do next is we're going to try to graph what is 3 cotangent of x using kind of the same method. So first thing I want to talk about here is what would the a value be in this situation? Well, looking at it, the a value is 3. And remember last time our a value was assumed to be 1, and that's why we went up 1 from our midline. We're not going to change the asymptotes. In fact, you guys can just cross that one off for now. The period is calculated by taking pi and dividing by b. Well, b in this case is the number in front of x, which is 1, and therefore period must be pi over 1, which is just pi. Just a little side note here, the way that we scaled this actually makes sense because quadrant is period over 4. Our period is pi over 4. So that means that our quadrant's pi over 4. You guys can see it's been scaled that way already, just from our basic cotangent memory quiz. From there, if I want to figure out if there is a phase shift, just set the inside equal to 0. If I set x equal to 0, that means there's no phase shift. So we don't have to worry about that. The only thing we have to worry about is the change in the a value. So typically, when our a value is 1, we go up 1 from the midline, but our a value is now 3, which means starting at my midline value and going to the left, I should now go up 3 instead of going up 1. And similarly, going to the right from the midline 1 quadrant line, I should go down 3 instead of going down 1. Connect this with a smooth curve as best you can. It's going to be kind of tough because it's so skinny. And that's what 3 cotangent of 1x is going to look like. So this is a little bit of a bonus question. It should be pretty easy though. I want you to now graph what's 1/2, not cosine, my bad. What's 1/2 cotangent of x going to look like? Okay, well 1/2 cotangent of x, when it goes to the left, instead of going up 1, it's going to go up 1/2 like this. And then when it goes to the right, instead of going down 1, it's going to go down -1/2. Connect that with a smooth curve like this, and we should get the green graph as followed. So when we change the a value of cotangent or tangent, we're really just saying, are we compressing it or are we stretching the given function? So let's move on to the next question. All right, our next question type has a lot more going on. What I want you to do first is I want you to graph the basic tangent function just like it was on a memory quiz. Okay, so taking a look here, this is our generic tangent graph. So what I want to do next is I want to answer some key questions to figure out what 1/2 tangent of x minus pi over 2 would be. So the first thing we need to identify is the a value. The a value is the value up front of tangent, which is 1/2. So think instead of going over 1 quadrant and up 1, we're probably going to have to go up 1/2 next time. Next thing, we want to discuss what the period is. The period is always not 2 pi, I'm muscle memory here, is pi over b for tangent and cotangent. Well, b is the number in front of x, and therefore pi over 1 is going to be our answer, or just pi. Our quadrant is going to be, conveniently enough, it's going to be our period, which is pi, divided by 4, which is why we have the given scaling. So that makes sense. Okay, let's keep going. Let's talk about if there is a vertical shift. I don't see any vertical shift. There's nothing that's being added or subtracted to the outside. And so we can just assume that there's none, and therefore we should probably sketch our midline at the x-axis. So we'll just say midline must be the x-axis. Lastly, our phase shift. Set the inside equal to 0 to find the phase shift. So 0 is equal to x minus pi over 2. We can add pi over 2 to both sides like this, and we'll solve for x. X must be pi over 2, which basically means that I need to move right pi over 2. All right, so that's all my information. Let's go through and check it off. Quadrant. Quadrant is done. I've already scaled my graph. So that's done. A value. We'll probably approach that a little bit later, so let's go on to something a little more important. Let's talk about the vertical shift. Vertical shift means we need to have a midline at the x-axis. So let's sketch our midline at the x-axis. That one's done. Phase shift. Okay, well, our phase shift basically says we're going right pi over 2. So what I want to do is I want to sketch where tangents should start. According to my tangent graph, which is way back here, tangent starts at the origin. So I'm going to sketch where tangent should start, and then I'm going to go from there. So tangent should start at this big black point right here, but we need to move right pi over 2. So I'm going to change my starting point of tangent to being pi over 2. And I'm going to sketch tangent in blue, by the way. Okay, from there, I'm going to sketch my quadrant lines just to kind of remind me what I'm doing. So we'll say quadrant line here. And remember, tangent kind of has quadrant lines that go to the left and right. So we're going to go left and right, 2 quadrant lines, just like tangent. From there, tangent goes right 1 quadrant, and it should go up the amplitude. Not amplitude, sorry, the A value, which is just a half, so it doesn't go up very much. And then going to the left, it should go down the amplitude, which is a half. The rest of the quadrant lines that are left over are going to be asymptotes. So I'm going to kind of like double highlight them so you guys can see that these are asymptotes right here. So I'm going to try to make them a little bit darker. Okay, and then all I'm going to do is connect with a smooth curve. And so we should get that the 1/2 tangent of x minus pi over 2 graph should look like this. Okay, let's do one more practice problem. All right, so we have 2 tangent of x over 3. Let's go through. First thing that I want you to do, we're actually not going to sketch tangent right off the gate here because it's going to mess with our scaling. So we're just going to try to answer this without sketching tangent first. First thing I want to figure out is the a value. My a value is always going to be the number out front of tangent, which is 2. From there, the period is going to be a little bit different. Remember that period for tangent is pi over b. Notice here how x over 3 is the exact same thing as 1/3 x. Therefore, b must be a third. Okay, so we're going to go ahead and say that this is pi divided by a third. If I keep it, switch it, flip it, this is pi times 3 over 1, which is equal to 3 pi. So my period is 3 pi. And let's go ahead and discuss the quadrant next. If my period is 3 pi, remember quadrant is equal to period over 4, that's got to be 3 pi over 4. So let's scale this by 3 pi over 4. Say 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4. And you can simplify that if you would like. Okay, so now that this is scaled, let's go ahead and put a check mark and let's keep going. Next question I want to figure out, is there a vertical shift? Well, I see no number being added to the outside here, so we're going to say no vertical shift. Let's assume that the midline is going to be the x-axis. So we can assume the midline is the x-axis. Let's go ahead and sketch our new midline. So here's our new midline here. All right, so let's continue. Let's go ahead and talk next about the phase shift. All right, so our phase shift is going to be basically when I set the inside equal to 0. So if we set x over 3 equal to 0, something divided by 3 is 0. Well, if you multiply by 3 on both sides, we get x equals 0. And so there is no phase shift. We don't have to worry about it. We can get rid of that one. Okay, let's go through and see if we can graph this. We need to, number one, remember that tangent starts at the origin. There's no phase shift, so we can literally just start tangent off at the origin. Okay, so then from there, let's go ahead and follow the tangent guidelines. Let's use a couple of quadrant lines just to kind of keep things straight. So I'm going to do 2 quadrant lines to the left, 2 to the right, because that's how tangent works. And then let's go ahead and follow the tangent pattern. Tangent goes over to the right 1 quadrant line and should go up an amplitude, or an a value, of 2, like this. Tangent should go to the left, though, and go down an a value of 2, like this. The rest of the quadrant lines are then assumed to be asymptotes. So let's go ahead and highlight them a little bit darker so we can identify that those are in fact asymptotes. So if we connect this all with a smooth curve, we should get that the tangent of x over 3 must be the following graph. Okay, and that was it for today. If you have any questions, feel free to send me an email.